class. Okay, so I hope the screen is now visible to all of you. So we were discussing about the Peterson solution for the critical section problem, and we have saw that Peterson solution is applicable only for two processes at a time, and we are having two processes P0 and P1, and they can also be represented as either Pi and Pj. And this was the very first algorithm which we have discussed in the last class, where we used to have one turn variable which has been shared between both the processes. And this turn can take either 0 value or it can take 1 value. And if the value of turn is equals to I, that means the process Pi is allowed to execute or enter into the critical section. So I have just shown you this code by executing this particular code for both the processes P0 and P1, and we have concluded that by using this particular algorithm, mutual exclusion is guaranteed, but the progress is not guaranteed, because this solution provides that if both the processes will enter the critical section alternatively, first P0, then P1, then P0, then P1, then it will be okay. But if any of the process do not want to enter the critical section, suppose P0 enters and exit, but after that P1 is not interested, then P0 will not again will be able to enter the critical section. So this was the problem with this algorithm 1. So today we will discuss two more algorithms to solve this drawback of this algorithm 1. So I'm just talking about algorithm 2 now. So here we can see that instead of turn variable, now we have used an array with the name flag, and this array consists of two elements and the data type is Boolean. So in the last algorithm, we have taken one turn variable, and now we are talking about this Boolean flag array. And as you can see, it is an array of two elements, and initially we will set both the elements as false, flag of 0 and flag of 1 both as false, because it consists of only two elements, that is flag of 0 and flag of 1. And what flag of I is equals to true indicates. So it is a Boolean array, so it can have only two values, either true or false. So if the value of flag of I is equals to true, that means the process Pi is interested in entering its critical section, or we can say Pi is ready to enter its critical section. So we have two processes here, P0 and P1. So if flag of 0 is equals to true, that means P0 is interested to enter the critical section, or if flag of 1 is equals to true, that means process P1 is interested in entering its critical section. And as you can see, this is the code. So just look at this code carefully, and we will discuss all the cases by taking this particular code. So here again we have the do while loop, but instead of using the turn variable here, now we are having a flag array here. And within the do while loop, you can see we have a condition. This is the general code for any process Pi. So if any process Pi wants to enter the critical section, so this will be the code. So first of all, that particular process Pi will set the flag of I equals to true, and then it will give the chance to another process while flag of j is equals to semicolon, then it will enter the critical section. And whenever that process Pi wants to exit the critical section, that will just simply set the flag of I is equals to false, and then we will have the remainder section. So this is the general scenario. We have used the turn variable, and instead of turn variable here in algorithm 2, we are using the flag array, which is of Boolean data type, which can contain either true or false value. And this is again the solution of the Peterson solution. So this is applicable only to the two processes. So just let me discuss this code for both the processes using the board once again for you people. Okay, so is the board visible to all of you? If anyone can confirm. Okay, thank you, Ayush. Okay, so this is the same code which I have just shown you in the slide. So I have written this code for both the processes P0 and process P1. So if P0 wants to enter the critical section, this will be the code. The process P0 will set the flag of 0 to true, then while flag of 1, and then critical section. And if P0 wants to exit the critical section, it will set flag of 0 equals to false, then we will have the remainder section. Similarly, if I talk about process P1, so if P1 wants to enter the critical section, it will set flag of 1 equals to true, and in the while we will have flag 0, then critical section. And if P1 wants to exit the critical section, it will just simply set the flag of 1 equals to false. So this is how the code will be written for both the processes, as Peterson solution is applicable to two processes. So now let's see one by one all the cases. What will happen if initially the process P0 wants to enter the critical section. So as you can see, initially, as you have seen in the slide, the value of both flag of 0 and flag of 1 is equals to false. So initially, flag of 0 and flag of 1 both are false. And as you know, if any value of flag is equals to 0, that means that process is interested to enter the critical section. Now I am starting with T0. So initially critical section is empty, none of the process is in critical section. So if suppose P0 wants to enter the critical section, this particular code will be executed. So first of all, process P0 will set the flag of 0 is equals to true. So the value of flag of 0 will be updated to true. And now there is a while condition again, so which is asking whether flag of 1. So whether flag of 1 is equals to true. So flag of 1 की value initially false है, so that means this particular condition will be false. And if it is false, there is a semicolon here, then definitely process P0 will be able to enter the critical section. So now P0 will be able to enter the critical section. And after that, if after performing all the tasks, and if the process P0 wants to exit the critical section, it will just simply set the flag of 0 is equals to false, and it will just simply exit the critical section. So this is how P0 will enter and exit the critical section. Now if P1 wants to enter the critical section, P1 will execute this particular code. First of all, P1 will set the flag of 1 is equals to true. So flag of 1 is equals to true, and it will just check what is the value of flag of 0. So flag of 0 is now false, because जब P0 में exit किया था तो उसने flag of 0 को false set कर दिया था. So flag of 0 will be false. So if this is false, there is a semicolon, then definitely process P1 will be able to enter the critical section, and after completing its all the execution, it will just set the flag of 1 is equals to false, and it will just simply exit the critical section. So this is how this particular code will work. Now just let me show you the concept of mutual exclusion. So in the case of mutual exclusion, we are just supposing initially both the flags are set to false, and once P0 enters the critical section and it is still in critical section, then what will happen if P1 wants to enter the critical section at the same time? So you can see initially if P0 wants to enter the critical section, it will just set the flag of 0 to true. So flag of 0 will be set to true, and it will just check whether what is the value of flag of 1. So flag of 1 is false, so definitely if it is false, in that particular case, this process P0 will be able to enter the critical section. Now P0 is in the critical section, so according to the critical section problem, at that particular time P1 will not be able to enter the critical section. So let's see what will happen if process P1 will be trying to enter the critical section at the same time. So P1 will execute this particular code. So it will just simply set the flag of 1 equals to true if this process P1 wants to enter the critical section. Now there is a condition while flag of 0. So here you can see अभी तक P0 exit नहीं हुआ है critical section से, तो flag of 0 की value true है. तो भाई जैसे ही यहाँ पे true value आ जाएगी, so this condition will become true and there is a semicolon, so this process P1 will be stick to an infinite loop. तो P1 एंटर नहीं कर पाएगा क्रिटिकल सेक्शन के अंदर जब तक यहाँ से P0 एग्जिट नहीं होता, जब तक हम कह सकते हैं फ्लैग ऑफ जीरो को हम फॉल्स सेट नहीं कर सकते. सो दैट मींस इन दिस पर्टिकुलर सॉल्यूशन the mutual exclusion is achieved, which was the very first mandatory condition for the critical section problem. Now let's discuss one problem we have seen in the last algorithm, which is where we have used the term variable. तो वहां पे क्या हो रहा था कि अगर प्रोसेस P0 एंटर कर गया, एग्जिट कर गया, then if P1 is not interested, then P0 again cannot enter the critical section. So just let us see whether such kind of problem is there in this algorithm or not. So I'm just again running this particular code. सबसे पहले P0 एंटर करेगा, एग्जिट करेगा, उसके बाद P1 एंटर कर सकता है लेकिन P1 is not interested to enter the critical section. Then P0 will again try to enter the critical section. Then we will see कि क्या दोबारा P0 critical section में enter कर सकता है या there will be some problem. So initially, if P0 wants to enter the critical section, P0 will set the flag of 0 equals to true and while flag of 1 false है, so P0 will be there inside the critical section, and after completing its task inside the critical section, the flag of 0 will be set again to the false, and definitely this after setting this flag of 0 equals to false, P0 will exit the critical section. It will execute rest of the instructions. Now there is a term, or better to say, if flag of 0 equals to false, that means this P0 is not interested. Now P1 can enter, but due to some reason the process P1 do not want to enter the critical section, and now after some time, let's assume again this P0 wants to enter the critical section. So let's see what will happen here. Now again flag of 0 will be set to true if second time the process P0 wants to enter the critical section, and now while flag of 1. So here you can see flag of 1 is false, so that means there will not be any problem for process P0 if any process wants to enter the critical section again. So this problem which was there in the initial algorithm, in the very first algorithm, has been solved here. Algorithm 1 में P0 एंटर किया, एग्जिट किया, उसके बाद अगर P1 इंटरेस्टेड नहीं था तो P0 एंटर नहीं कर पा रहा था. बट इन दिस पर्टिकुलर कोड यूजिंग दिस फ्लैग array, first of all P0 enters the critical section, it exits the critical section. After that, even if P1 is not interested to enter its critical section, P0 can again enter as many times as it wants to enter the critical section. Now what is the problem with this particular solution? So let's just discuss that. So वो वाली प्रॉब्लम हमारी इसमें सॉल्व हो गई है, जहाँ पे एक प्रोसेस जितनी मर्जी बार जाना चाहे वो एंटर कर सकता है क्रिटिकल सेक्शन में, इवन इफ द अदर प्रोसेस इज नॉट इंटरेस्टेड टू एंटर द क्रिटिकल सेक्शन. देखो प्रॉब्लम क्या आएगी यहाँ पे, अगर एक टाइम पर दोनों प्रोसेसेस इंटरेस्टेड हो जाएंगे क्रिटिकल सेक्शन में एंटर करने के लिए, दोनों अपने फ्लैग की वैल्यू को अगर ट्रू सेट कर देंगे, इन दैट there will be a process of all P0 wants to enter the critical section. तो भाई जैसे ही P0 enter होना चाहेगा, it will just set the value of its flag to true. So flag of 0 will set to true. Now let's suppose ये वाली इंस्ट्रक्शन फर्स्ट इंस्ट्रक्शन एग्जीक्यूट हुई जहाँ पे फ्लैग ऑफ 0 ट्रू सेट हुआ था, और नेक्स्ट इंस्ट्रक्शन एग्जीक्यूट होने से पहले ही ड्यू टू सम रीजन प्रीएम्पशन की वजह से कंटेक्स्ट स्विच हो गया और जो कंट्रोल है वो P1 के पास चला गया. नाउ P1 इज आल्सो इंटरेस्टेड टू एंटर द क्रिटिकल सेक्शन. तो अगर ये वाली वाइल कंडीशन चेक हो जाती देन डेफिनेटली P0 एंटर कर जाता हमारा क्रिटिकल सेक्शन के अंदर, लेकिन P0 ने डू वाइल लूप की फर्स्ट स्टेटमेंट ही एग्जीक्यूट की थी जहां पे उसने फ्लैग 0 को ट्रू सेट किया. ड्यू टू सम रीजन कंटेक्स्ट स्विच हुआ, नाउ सीपीयू के पास प्रोसेस P1 पहुंच गया, नाउ P1 की इंस्ट्रक्शंस एग्जीक्यूट होनी स्टार्ट हो गई. नाउ हियर यू कैन सी P1 की क्रिटिकल सेक्शन में जाने के लिए इंटरेस्टेड है, नाउ P1 will set this flag of 1 is equals to true also. So now both the processes P0 and P1 are now interested to enter the critical section. So now you will see what will happen. So now if suppose P1 की instructions ही execute होती रही तो flag of 0 भी true हो गया, flag of 1 भी true हो गया, now flag of 0. So यहाँ पे जब condition check होगी तो flag of 0 की value true है तो भाई ये true है तो ये infinite loop में फंस जाएगा. एंड सपोज इस स्टेटमेंट के बाद अगर दोबारा P1 भी प्रीएम्प्ट हो गया तो अगर P0 एंटर करने की ट्राई करेगा क्रिटिकल सेक्शन में तो वाइल फ्लैग ऑफ 1 तो भी फ्लैग ऑफ 1 की वैल्यू भी ट्रू है तो P0 भी एंटर नहीं कर पाएगा. सो दिस पर्टिकुलर सिचुएशन इज नोन एज डेडलॉक कंडीशन, डेडलॉक सिचुएशन, जहां पे दोनों ही प्रोसेसेस P0 और P1 एंटर नहीं कर पाएंगे अपने क्रिटिकल सेक्शन में. एंड दिस विल हैपन इन द वर्स्ट केस just because both of the processes are interested to enter the critical section at the same time and due to some reason इस स्टेटमेंट के बाद प्रीएम्पशन होने के बाद P1 के पास कंट्रोल चला गया और P1 ने भी अपना फ्लैग की वैल्यू को ट्रू सेट कर दिया. So if both the processes will set their flag values equals to true in this particular case in algorithm 2, so there will be a problem which is known as the deadlock situation. So we will discuss in detail also. We have the next complete chapter related to the deadlock and I hope the things are very much clear to you. So let me present the screen once again. Okay, so I hope the screen is now visible to you. So this is second solution to the Peterson solution, the second algorithm where we have used the flag array instead of the turn variable. And this was the general algorithm as you can see for PI process. Flag of I equals to true while flag of J and flag of I equals to false is the condition for the exit. And it definitely satisfies the mutual exclusion, but the progress, which is the second condition for the critical section problem, is not met here. And this is the scenario if both flag of I and flag of J will be set to true, then definitely there will be a deadlock situation, and in deadlock situation, none of the process will be able to enter the critical section, and that simply means there will not be any progress. तो भाई कोई भी process ना P0 enter कर पा रहा critical section में, ना P1 enter कर पा रहा, so none of the process will be able to access the critical section to update the values. So this is the problem with this particular solution. This is algorithm 2. And now finally I am just moving on to the last solution, which is the actual solution where we will be able to deal with the mutual exclusion also as well as the this problem of progress also. So this is the actual solution of Peterson solution. Initial two solutions I have just explained to understand this algorithm more accurately. So Peterson solution is a two-process solution. Now lastly, we will combine these two variables, turn and flag array, in a single program. And as you already know, the variable turn indicates whose turn it is to enter the critical section, and the flag array is used to indicate if the process is ready to enter the critical section. So if the value of flag of I is equals to true, that means the process PI is interested to enter or it is ready to enter the critical section. So this is some initial assumptions which we have to make. So turn is an integer variable that can have only two values, either 0 or 1. Initially, both the flag values will be set to false, and turn initially can have any random value, either 0 or 1. And this is the simple structure of the last third algorithm, which you can see. And just let me write the code for both of the algorithm on the board so that this thing will be understood more clearly. So as you can see, this is the solution where we have a do while loop again, and within the do while loop, now instead of taking a single value, that is either turn variable or the flag array, we have combined both turn variable and the flag array. So just let me write the code on the board for you so that that thing will be much more clear to you people. And with the code now you can have an idea also that how the things will work, and it will definitely solve both the problems of mutual exclusion will also be solved here, and the problem of progress which we were having in both the algorithms that was not satisfied, that would also be solved using this solution where we have combined both the term variable as well as the flag array. So just give me 2 minutes. Okay, so I have just wrote the code and let me explain you it once again. Okay, so this is the code for both the processes. If I talk about the last algorithm, which is third algorithm, where we have used both the term variable as well as the flag array, and initially both the flag of 0 and flag of 1 is equals to false, and turn can start with any value. It can be 0 or it can be 1. So if we start with process P0, the turn will be 0, and if we will start with process P1, the turn value will be 1. So let's assume that the value of turn is initially 0. So this is the code, and if suppose P0 wants to enter, so I will just discuss all the same cases, but we will see mutual exclusion के साथ we will be able to achieve the progress here. So let's see how this thing will happen. So initially if P0 wants to enter the critical section, what P0 will do? P0 will set the value of flag of 0 equals to true. तो भाई खुद के flag की value को 0 set करेगा. Now this flag of 0 will be true, and turn को हम क्या सेट कर देंगे? Now turn will be updated from 0 to 1 here. Now condition to enter the critical section is here in the while loop. So while turn is equals to 1. तो भाई क्या turn की value 1 है? बिल्कुल 1 है. So that means this particular condition is true, and between these two conditions there is an and means दोनों true होनी चाहिए तभी true होगी. Now second condition is what is the value of flag of 1. So in here initially you can see the value of flag of 1 is equals to false. So that means this flag of 1 will be false, and there is an and between these two conditions. So true and false will be false. So overall the result of this while loop will be false. So false means definitely the process P0 will be able to enter the critical section. Now P0 will be able to enter the critical section, and to exit the critical section the condition is again same, just P0 will set the flag value of 0 to false, and it will just simply exit the critical section. So P0 will exit the critical section by setting the value of flag of 0 equals to false. So this is how the process P0 will enter the critical section, and it will exit the critical section after setting the value of flag of 0 equals to false. Now let's suppose if P1 wants to enter the critical section, what it will do? P1 will just set first of all the value of its flag of 1 to true. So flag of 1 to true set करेगा. Turn की value को now it will update from 0 to 0. So turn की value 0 1 थी, so it will be updated to 0. Now the condition will be checked. While turn is equals to 0. तो भाई क्या turn की value 0 है? Definitely turn की value 0 ही है. And what is the value of flag of 0? तो भाई flag of 0 false हो गया था जब P0 ने exit किया था. So it will be false. So here is an and. So true and false will be false. Now definitely P1 process will also be able to enter the critical section. Now just let me discuss the same example, same case कि अगर P0 already critical section में है, चलो इस बार हम ऐसा करते हैं कि P1 enter कर गया है यहाँ पे, P1 is in critical section, And these are the updated values. Now let's suppose if P0 wants to enter the critical section at the same time, what will happen? So अगर P0 ने enter करना है critical section में तो वो flag of 0 की value को true करेगा. So flag of 0 will be set to true and turn की value को 1 करेगा. अभी P1 ऑलरेडी क्रिटिकल सेक्शन में है और P0 is trying to enter the critical section. Now this particular condition will be checked for the process P0. So while turn is equals to 1, कोई turn की value 1 है, yes, turn is equals to 1. And what is the value of flag of 1? Flag of 1 भी true है because अभी P1 critical section के अंदर है, वो exit नहीं किया है flag of 1 को false set करके. तो अभी तो वही जो flag of 1 की value है that is true. So true and true will give you true. So that means process P0 will not be able to enter the critical section just because P1 is already updating or making changes in its critical section. So this is how this condition of mutual exclusion you can check this will be achieved. Now let's talk about the progress. What will happen to the progress here? So एक condition हमने discuss की थी कि अगर P0 enter करके exit कर जाता है, उसके बाद P1 interested नहीं है, and if P1 is not interested and P0 wants to enter again, तो क्या P0 दोबारा से enter कर पाएगा? So I'm just discussing that particular case. And after that जो problem हमारे को last algorithm 2 में आ रही थी डेडलॉक वाली, उसको भी डिस्कस करेंगे कि क्या हम डेडलॉक को हटा पा रहे हैं इसमें या इसमें भी हमें डेडलॉक वाला इशू मिलेगा. तो उससे पहले एक सिंपल सा P0 एंटर करेगा क्रिटिकल सेक्शन में, P0 एग्जिट करेगा, P1 इंटरेस्टेड नहीं है, देन P0 को दोबारा देखेंगे क्या वो इस केस में क्रिटिकल सेक्शन में दोबारा एंटर कर पाएगा या नहीं, उस चीज को डिस्कस करते हैं. आफ्टर दैट वी विल जस्ट ट्राई टू सॉल्व द इश्यूज ऑफ डेडलॉक रिलेटेड विद द एल्गोरिथम 2. So P0 wants to enter, it will just set the value of flag is equals to true, turn की value को 1 से अपडेट किया, while turn is equals to 1 ये true है, flag of 1 false है, so true and false will be false, so definitely P0 will be able to enter the critical section. अपनी अपडेशन करने के बाद P0 एग्जिट कर जाएगा, तो जब जैसे ही P0 एग्जिट करेगा तो फ्लैग ऑफ 0 की वैल्यू को फॉल्स सेट कर देगा. तो भाई फ्लैग ऑफ 0 की फॉल्स वैल्यू को फॉल्स सेट करके P0 विल एग्जिट. नाउ P1 को उसने बोला कि P1 कैन एंटर द क्रिटिकल सेक्शन बट ड्यू टू सम रीजन process P1 is not interested to enter the critical section. Now after some time P0 again wants to enter the critical section. So again P0 will set this value of flag of 0 equals to true and turn is already 1, so turn को update करके 1 करेगा, already 1 ही था. Now while turn is equals to 1, true है, flag of 1, so flag of 1 अभी भी false है, so true and false will be false, so there will not be any problem for process P0 if process P0 wants to enter again and again when or while P1 is not interested, so there will not be any issue. P0 can enter any number of times. So same is the concept with process P1. तो अगर P1 ने पहले enter किया, exit किया, and after that P0 is not interested, then there will not be any problem for process P1. P1 will be able to enter as many times as the process P1 wants to. So this is how the things will work. Now just let me discuss the last case for today, where we will have to see what will happen when both the processes will be interested to enter the critical section at the same time. So I'm just starting once again for both the processes. So turn is initially 0 and both the flags are false. ओके, सो मैं यहाँ पे बात करूँगा P0 ने एंटर करना चाहा और उसके बाद P1 भी साथ के साथ अगर दोनों ही इंटरेस्टेड हो जाते हैं, जो हमने लास्ट केस डिस्कस किया था, दोनों अपने फ्लैग को सेट कर देते हैं ट्रू पे, तो उस केस में कि यहाँ पे डेडलॉक की प्रॉब्लम आएगी या फिर ये वाली प्रॉब्लम को हम यहाँ पे सॉल्व कर पाएंगे. सो इनिशियली P0 wants to enter the critical section. P0 will update the value of flag of 0 to true and it will update the value of this flag to टर्न। तो भाई P0 क्रिटिकल सेक्शन में एंटर करना चाहता है तो उसने फ्लैग ऑफ 0 को ट्रू सेट किया, टर्न की वैल्यू को 1 सेट किया, लेकिन जैसे ही वो वाइल वाली कंडीशन नेक्स्ट लाइन पे जाने वाला था तो यहाँ पे कंटेक्स्ट स्विचिंग हो गई, प्रीएम्पशन हो गई। नाउ जो सीपीयू है वो P1 के पास है। नाउ P1 इज अगेन आल्सो इंटरेस्टेड टू एंटर द क्रिटिकल सेक्शन। तो भाई P1 प्रोसेस क्या करेगा अपने क्रिटिकल सेक्शन में जाने के लिए, फ्लैग ऑफ 1 को भी ट्रू कर देगा and it will update the value of turn variable to 0 now. So instead of 1, now the process P1 will update the value of this turn variable to 0. Now let's see if दोबारा पेंशन हो जाती है, सपोज P0 के पास कंट्रोल आता है तो क्या P0 एंटर कर पाएगा या नहीं? सो लेट्स सी। सो while turn is equals to 1, तो टर्न की वैल्यू क्या 1 है? नहीं, टर्न की वैल्यू 0 हो चुकी है। सो दैट मींस दिस पर्टिकुलर कंडीशन विल बी फॉल्स एंड फ्लैग ऑफ 1, दोनों फ्लैग की वैल्यू ट्रू है बट ट्रू एंड फॉल्स विल बी फॉल्स। सो दैट मींस P0 will be able to enter the critical section. So as you can see, लास्ट वाले एल्गोरिथम 2 में हमें क्या प्रॉब्लम आ रही थी, जब दोनों फ्लैग ट्रू सेट हो रहे थे, फ्लैग ऑफ 0 एंड फ्लैग ऑफ 1, तब डेडलॉक कंडीशन आ रही थी, कोई भी प्रोसेस एंटर नहीं कर पा रहा था क्रिटिकल सेक्शन में। बट नाउ यूजिंग दिस एल्गोरिथम 3 यू कैन सी इवन इफ यहाँ पे प्रीएम्पशन हो गई, प्रोसेस P1 ने ही अपने फ्लैग को ट्रू सेट कर दिया, P0 ने इसको ट्रू सेट कर दिया था, लेकिन इसने टर्न की वैल्यू को 1 से 0 अपडेट कर दिया था। उसके बाद अगर दोबारा से कंट्रोल P0 को मिलता है, then definitely P0 will be able to enter the critical section. So what is the reason? ऐसा क्यों हो रहा है? तो यहाँ पे भी प्रोग्रेस भी अचीव हो जाएगी, प्रोग्रेस भी नहीं रुकेगी। If any process do not wants to enter, next process can definitely enter, and definitely the problem of deadlock will not be here. So reason क्या है यहाँ पे एग्जैक्ट जो हम इस deadlock situation को डील कर पा रहे हैं? तो भाई अगर फ्लैग दोनों सेट हो जाते हैं ट्रू, that will create a problem. But here जो actual रोल है वो कौन प्ले कर रहा है? टर्न वेरिएबल प्ले कर रहा है। टर्न इज एन इंटीजर वेरिएबल जिसकी वैल्यू या तो 0 हो सकती है या तो 1 हो सकती है। तो भैया अगर टर्न की वैल्यू यहाँ पे 0 हो जाएगी तो टर्न की वैल्यू 0 होते ही ये वाली कंडीशन दोनों ट्रू हो जाएंगी। तो इसका मतलब कि प्रोसेस P0 है वो एंटर कर पाएगा क्रिटिकल सेक्शन में, और अगर टर्न की वैल्यू 1 रहती है, टर्न की वैल्यू 1 रहेगी तो ये वाली दोनों कंडीशंस ट्रू हो जाएंगी। दैट मींस प्रोसेस P1 will be able to enter the critical section. So by combining both the flag array and the turn variable, we can achieve both mutual exclusion as well as progress. Even the third condition and critical section problem की, that is bounded waiting, that will also be achieved using this particular solution. So this is the complete entire solution algorithm 3, which consists of both the flag as well as the turn variable. This is the complete and entire solution for this critical section problem, which is the exact Peterson's solution. So I hope the things are very much clear to all of you. And for now, for today, I'm just stopping myself here, and you can just let me know if anyone having any issue with whatever I have explained you for now. So just let me complete the slides. Okay, so this was the general code. तो इस कोड के लिए मैंने दोनों process P0, P1 को लिखा, and using this particular algorithm, we can see that mutual exclusion is preserved, progress is satisfied, as well as bounded waiting will also be satisfied, and it definitely meet all the 3 requirements, and it will solve the critical section problem for 2 processes. And this turn variable will break any deadlock possibility of the previous examples as we have seen. And this flag variable prevents getting locked out if any other process do not want to enter the critical section. And similarly, they have just taken one example as I have explained you completely. So initially they have set both the flags to false and turn equals to 0. That means we will start with process P0, and this is how the entire thing will work for process 0. I will be equals to 0, so flag of 0 will be true, turn will be set equals to 1. So in the while loop we will check the things, and this is how the things will work. So this is all for today. We have completed the first solution for which is known as the Peterson solution to solve the critical section problem, where we have saw the three different algorithms. So algorithm 1 and 2 were lacking somewhere, but the last solution which I have just explained will solve the critical section problem entirely. And in the next few lectures, we will see some other interesting solutions using logs, using test and set instructions, how we can achieve the critical section problem using various other solutions. So I hope the things are clear. Dominic explained here, you will be able to understand. So just